Hello, Science 30. Welcome to our next lesson on wave equation. Today we are going to investigate and describe variables in the universal wave equation. So we're going to be looking at how to solve for different constants, understanding what the wave equation is used for, and move around a formula. So essentially calculating wavelength and frequency. So you remember from our last video, we learned what a wavelength was and what a frequency is. So a wavelength is from the top of a wave to the top of a wave, or a bottom of a wave to a bottom of a wave. And the frequency is how many times it does that in a time frame given. So we can use an equation that allows us to solve for the frequency, the wavelength of the electromagnetic radiation spectrum. So normally you would velocity equals frequency times wavelength. So velocity is measured in meters per second, frequency is measured in hertz, and wavelength is measured in meters. However, for our purposes, we are going to be using the constant of 3.00 times 10 to the 8th meters per second. Now, the formula we're going to use, C equals frequency times wavelength, comes from the fact that the electromagnetic waves in the spectrum, all of them, including visible light, will travel. Is given right there, 3.00 times 10 to the 8 meters per second. So we're going to use this formula instead of velocity. It's a little bit easier as we don't have to constantly solve for velocity. Instead, we are given a constant that is found in your data book that you can use. So let's do some practice problems. We're going to determine the wavelength of the EMR emitted by 60 Hertz AC transmission line. So whenever starting a problem, you want to write down your constants, or you want to write down what you know, I should say. So in this question, we know that the frequency is 60 Hertz. It asks us to determine wavelength. So we don't know that yet, but we do know the constant of light is 3.00 times 10 to the 8th meters per second. Now what we want to do is we want to write out our formula. C equals frequency times wavelength. However, we want to solve for wavelength. So we need to make sure that we switch our formula. In order to do that, we're going to bring frequency to the other side. Wavelength is going to equal the constant divided by the frequency. So we're going to divide the frequency to the other side. So I'm going to take my constant of 3.00 times 10 to the 8th, and I'm going to divide it by my frequency. Now, as I write down this frequency, what you have to remember, guys, is when you start to put this in your calculator, you need to put it in correctly. Use your brackets, use your second function and your E button to put it into the calculator properly. Then divide it by your 60 Hertz. You're going to end up with a very big number, 5 million to be exact. So when you write it out, you're not going to use a very big number. Instead, you're going to put it in what we call scientific notation, which is essentially finding a number between 1 and 10 and then moving your decimal to create your 10 to the whatever. So I moved the decimal 6 times. So let's try our next practice problem. A cell phone operates on a frequency of 800 megahertz. Determine the wavelength of the electromagnetic wave. This one, we want to make sure that when we write down our frequency, we recognize that this is in megahertz and not just in hertz, which is a problem because we need to convert it. So what we're going to do is a conversion to help us figure out what megahertz is in hertz. So we want to take the biggest number and put it on the bottom. So megahertz goes on the bottom. And for every 1 megahertz, we want to figure out how many hertz there are. Okay, there is 1 million hertz in 1 megahertz. So what we have to do is we take our number, 800, and we multiply it by 1,000,000. So here's my number, 800 million hertz. So now I want to solve for wavelength. So C equals frequency times wavelength. I'm going to move my formula around like I did last time, dividing out frequency. And I'm going to end up plugging this into my calculator as 3.00 times 10 to the 8 meters per second divided by 800 million hertz. Now again, you could put that into scientific notation if you want. You can leave it like this if you want to. It'll make it easier to put into your calculator. So I'm going to type in my 3.00 times 10 to the 8. Remember, using your second function button and your brackets. And I'm going to divide it by 800 million. I'm going to end up with 0.375. So now I'm going to look at a problem that's a little bit different than the ones we've done so far. This one says find the frequency of an AM band radio wave with a wavelength of 390 meters. So I know that I have a wavelength of 390 meters. That is my known. I also know that I have a constant. Here's my formula. I'm going to try and solve for frequency this time. So this time I'm going to divide out wavelength. So my new formula is frequency equals my constant over my wavelength. So I'm going to write down my constant of 3.00 times 10 to the 8 meters per second, and I'm going to divide it by my wavelength of 390 meters. Plugging it into the calculator. Again, make sure second function e to the 8th, you have your brackets. Here we go. So now I have 760,230.7629 hertz, because I'm solving for frequency. Again, I'm going to put it into scientific notation to make sure that I have the correct frequency, and I accidentally wrote meters. So again, for that last one, guys, please ignore the mistake. I wrote meters instead of hertz. We were solving for frequency. We're going to solve for the wavelength of FM radio stations that emit 102.1 megahertz. So again, I make sure I know my constant. My frequency is 102.1 megahertz, but you should recognize from last time that we do not use megahertz. We want to make sure that we put it in the correct units. So megahertz goes on the bottom because it's the biggest. Hertz goes on the top. For every 1 hertz, there is 1 million. For every 1 megahertz, there's 1 million hertz. So again, I'm going to plug it into the calculator, and I'm going to get a very large number. So now I have my frequency written down. I'm going to solve for my wavelength. Wavelength is my constant over frequency. Don't forget to put your original and then show how you got there. So wavelength is constant over frequency. I'm going to put it down with my 3.00 times 10 to the 8th. I'm going to put my frequency that I wrote up above. I don't need to put it in scientific notation yet, guys, because again, significant digits in scientific notation are not important at this moment because you're doing a division. It's the answer that matters. So I'm going to end up with 2.938 meters. So that's it. Hopefully you understood all of the different calculations we did, and I will talk to you soon.